Hello and welcome to Investigation 4.4. In this investigation, we are going to be modeling with functions, and so our sort of question that we have here is, what is the function? So our job will be to determine if something is linear, exponential, inverse, quadratic, or maybe none of those, and then we're going to be playing around and creating a couple of equations and that sort of thing. So let's get started. The parameters for this. For the following situations, we need to, number one, determine whether this situation can represent a linear, an exponential, a quadratic, or an inverse variation, or none of these. We then need to write an equation that represents the function, and then we also need to write the problem and solve it using the equation that we create. So let's get started. Our very first one that we have is this. Number one. A cylinder has a height of 16 inches. Consider the relationship between the volume and the radius of the cylinder. So, first of all, we need to know a couple of things. We need to know how to find the volume of the cylinder, and we need to maybe manipulate it a little bit so we can see what's going on. So I'm going to draw a little picture of what a cylinder kind of looks like. We have essentially a tall, round, can-looking thing. So it would essentially look a little bit like this. We would have essentially a circle on the top, circle along the bottom, and it has a certain height. In this case, it has a height of 16 inches. Now the volume for a cylinder can be given with this equation, and you might want to write this down for a future problem. I believe problem number 5 is also about the volume of a cylinder. The volume of the cylinder is essentially looking at the area of the base, timesing it by the height. So we have the area of the base times the height. The area of the base is the area of a circle. So the area of a circle is pi times the radius squared times the height. So that is our volume equation. Here's the area of our circle times the height of that particular cylinder. So let's write a little bit of an equation. We don't know what the radius is, and that's the point. We need to look at how the radius of this cylinder is compared to the volume. One thing we do know is the height, however, so we can write that in as 16. So we can rewrite this equation as saying we have 16 times pi times the radius squared is equal to the volume. So looking at the relationship between the radius and the volume, I can see because the radius is squared, we have a quadratic relationship. So that is our very first thing that we can say. We have a quadratic, relationship. It's quadratic. As well, just by doing this, by playing around with this and manipulating it, we created an equation. So the very last bit of this particular problem is we need to write a problem. So I'm going to write a problem. Just one moment, math magic. So my problem that I created is this. Justin is designing a paint can that needs to fit into the shelves of height 17 inches. That's what it should say. He decides to maximize this space by creating a can with the height of 16 inches. What is the volume of the can if the radius is 4 inches, and what if it is 5 inches? So essentially we're going to use our equation that we created, this 16 pi r squared is equal to the volume, to play around with 4-inch volume and 4-inch radius and 5-inch radius. So we have 16 pi times 4 squared is equal to the volume, or we have 16 pi times 5 squared is going to be our volume. So after that, it's just plug and chug. Let's get it figured out, and let's figure out what the actual volume is. The volume for this situation is going to be 1,256 inches cubed because it's volume. And the volume for our other paint can would be 803.8 inches cubed. So those would be our two volumes. We've just solved an equation. Actually, we've solved two equations, and we figured out that this particular situation is quadratic. Our next one, number 2. The rectangle has an area of 24 square inches. Consider the relationship, that's what it should say, relationship between the length and the width of the rectangle. So if we have a rectangle, its length and width are associated with it. As you notice, I'm yet again drawing another picture so I can see what's going on. And its area is equal to 24 square inches. That means anything that I have for my width needs to correspond to the length to make a 24-inch area. So we know that the equation for area is equal to length times width. That's what we got going on for a rectangle. And we have a fixed area in this case, so that means it's 25 times length times width, or 25 is equal to length times width. If I think about this sort of situation, if I have a fixed area, my length and my width are going to sort of seesaw back and forth. It's going to go, we'd have a length of 1 and a width of 24, a length of 2, a width of 12, 3 and 8, 4 and 6, and then it would be 6 and 4, and it sort of seesaws. It goes, if one of them gives a little bit, the other one has to take it up to make, oops, I wrote 25 over here. The other one has to take a little bit to make sure it stays balanced. So this is a prime example of an inverse variation. Awesome. So we have an inverse variation equation. So now let's actually write a problem. Now here is our equation, or here is our scenario. Diane is building a dollhouse for her daughter. The area for the living room will be 24 square inches. What is the most feasible dimensions for the living room, and why do you think so? Most feasible dimensions for this living room, if you ask me, are somewhere around the 4 and 6 or 6 and 4 range, because then we have the most space for potentially a little bit of furniture and that sort of thing. If we were going to have a 1 by 24 or a 2 by 12, we have a really long, skinny room. It might not be the best for the dollhouse. There's not a lot of space in there. So that would be a potential equation or a potential scenario that we could use. So now let's move on to our very last equation. Oops, we got all sorts of craziness going on here. Let's move on to our last equation. And we have this. Number 3, a laptop costs $800 and loses 50% of its value per year. Consider the relationship between the value of the laptop and time. So let's think about this. This time we don't need to draw a picture because I don't think a picture of a laptop is really going to help us. However, maybe making a table could. So if we were looking at time versus value, we could say initially, in the first year before, or when they first purchase a laptop, we have that starting value of $800. After the first year, that value has decreased by 50%. So that means our value is now $400. After 2 years, the value has again decreased by 50%, so now it's $200. In 3 years, again, 50% decrease, $100. In 4 years, we got $50. So this obviously could go on for a while. We could essentially say that the value of this laptop, while it starts at $800, there's my y-intercept, it's decreasing by 50%. So this is an ideal exponential relationship. This is telling me that I have a decay factor less than 1, so that's why it decreases each time. And here's my starting value of $800. So depending on if I put 4 in for x or just 1 in for x, we'll get an answer that's from our table. So we have now our equation. We have the type of function it is. Now we need to create a little scenario. So math magic, just one moment. And here's our problem. Helen wants to purchase Sal's laptop. He owned the computer for 4 years. If its initial value is $800 and its worth decreases by 50% each year, how much should Helen pay for the laptop? We've already done the math. At 4 years, she should just pay $50. So she is getting this laptop for a steal. Hopefully it works. So your job now, I've done 1, 2, and 3 of this investigation. Your job is to do numbers 4 through 8 and Part B. So this is A, 4 through 8, and Part B. So you are figuring out if something is a quadratic relationship, a linear relationship, exponential, inverse, or none of them. Trust me, you'll have at least one none of them, but you won't have more than one. Enjoy. Make sure you ask questions if you get confused, and as always, have fun. Yay! Bye!